Okay, my friends, here we go. So let's take a look at a few things. This problem, yes, we can plug it into Desmos, and we can figure out the roots. Remember, a root is where it's going to cross the x-axis, or when plugged in, gives an answer of 0. Okay?
Hello, boy.
All right. So that's kind of the first thing we need to go decipher. All right. So again, if you have this out, I will give you the points for it. If you don't have it out, you're sitting there doing nothing, I'm going to make fun of you.
No, get it out. No, I've been happy, bro. It should be charging.
Come on. There we go. All right. So a few things that stick out with this problem is because the denominator is this, that means that x can't equal -2. Is that a root, though? If it can't equal something, can it be a root? Okay, so this is not a root. It's on the page after 5.1 worksheet. You know what I should do next year? If I don't get these copied the right way, I should, first day of class, all right, everyone, mark your pages 1, 2, 3.
Oh, why don't you give a page number?
This workbook is as old as me, and I don't want to have to go in and number them. All right, so x equals -2 is not a root. So a couple other things that we're going to look at. Let's take a look at the top. The top would break down to x plus 4 and x minus 4. Okay, because they're different 2 squares. So my friends, if I had x equals -4 or I had +4, if I plugged each of these in, would that make the top 0? And if the top of the fraction is 0 and the bottom of the fraction is not 0, does that make the answer 0? Top 0 is fine, right?
Yeah.
0 over 0 is undefined, which you probably figured that out when you were a kid going 0 divided by 0 on your calculator said error, and you're like, oh. Why did that happen? Okay, so I would say these have to be the roots. And I don't think there's any other roots. Now, if you plugged it into Desmos, I would bet you would find that it does appear that it's crossing at -4 and +4. So let's just for the sake of laughter, take a look at it. So let's just plug it in, go to our friends, the Desmos family. So I got y equals blah, 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 blah. All right, so let's do square root on top. X squared minus 16 over x plus 2. Okay, so if I go here, this is what the actual graph looks like. So it's a little goofier looking, but I definitely have a point that exists being -4, 0 and 4, 0. So that's where we definitely have roots. So we've used algebra to show where the numerator would be equal to 0. That defined for us the roots. Okay? And then the denominator where x could not equal -2. Well, -2 is just this bound region that's not even working. So like this is no man's land in between there where -2 happens to fall somewhere in there. So that's kind of the thought process on this problem. Okay? So, and again, Desmos is always available for you. So we can do with that. All right. So they give us the derivative. They give us the derivative on the next one. It said, hey, we happen to have this derivative. And I'm not sure what the original function was that gave us that derivative. But they said, hey, this is This is the derivative of some higher ordered function. And we want to know where this is increasing or decreasing. Okay. So a few things that might stick out is -3 can't happen. But at top, I know because of the x squared, I know this. And because the x minus 2, I know this. I bet you these are probably some sort of roots. So what I'm going to do is I'm just going to draw my f prime line. And I'm going to put my two roots that I know, 0 and 2. I'm not too concerned at this -3. I'll mark it right here. This is going to be an undefined situation. So I bet you it probably would look like an asymptote on the original problem, but we're not sure. So let's take some values. Now, some tricks to do on the sine line that sometimes work. It's sometimes easier to go way out here. So like if we plugged, say, 100 in, I get 100 squared times 98. That's a positive number. 100 plus 3 is also a positive number. So way out here, it's going to be positive. Okay, that's what the slope is. That's where it's increasing. So then we wanted to look at and think about something that's between 0 and 2. So if we plugged 1 in, this would be 1, and that's a -1 over 4. So that gives me a negative answer. So I think right here is going to be negative. And then I have this undefined point, so, I don't know, maybe see if I can plug in. What would happen if I plug, say, -2 in? What's that going to do to things? That's going to give me a positive, and that's going to give me a negative. So positive times a negative. So if I plug -2, this would be positive, this would be negative over a positive. So that's going to give me a negative. So something's taking place right there. But then let's take, say, -100 and plug it in and see what's going to happen. So I took -100 in. The first part's positive. The second part is negative. And then it's over a negative. So something way out here is happening to be positive. So we do have this sine line that continues a little bit further on this. So basically you have some sort of increasing function. This is taking place, showing you some sort of decreasing, and then some sort of increasing on the original function. And again, I don't know what the original function is because they gave us the derivative, and I haven't taught you how to do antiderivatives yet. In fact, that's a really ugly antiderivative if we actually went through. Antiderivative is called the integral usually. But that's basically what our graph is doing. The lines that are going certain directions, that's just kind of, maybe it's going up or down at those regions. And at the 0, it's changing a little bit different to the slope. But again, we don't know exactly what the original graph is because we haven't learned how to do antiderivatives yet. Okay? But, well, you won't learn in this class, and I'm sorry. I know you're looking forward to it. Y'all came in first day of class going, dude, we hit the antiderivative this year. And well, we're not. I'm sorry. I let y'all down. So, we good?
Mm-hmm.
All right. And then number 3 says, so determine the intervals where it's increasing or decreasing. Okay, so yes, we could use Desmos, or I could take the first derivative of this. If I take the derivative, I'm going to get 15x to the 4th minus 15x to the 2nd. And then we could solve that, set this equal to 0. Set it equal to 0. So just to make it easier, I could factor a 15x squared out of both. That leaves me x squared minus 1 equals 0. So this is going to give me 0 for an answer. This will give me positive 1 for an answer and negative 1 for an answer. So let's take a look at our f prime chart, or g prime chart. Excuse me. So I'm going to plug in, I have -1, I have 0, and I have positive 1. Okay? So using our using our derivative here, if I pick a value way out, say if I pick 10, or even 100, this is going to be a really big number, which is positive. So right here, it's a positive slope between 0 and 1. So if I pick, say, 0.5, and I plugged it in, 0.5 raised to the 5th power is big old decimal times 3 minus this. This is going to give me a negative value if I plugged it in. If I plugged negative 0.5 in, this gives us a real big negative, another a negative, something like that. So that's going to give me another negative situation that's taking place. And then if I were to pick, say, something way out here, say negative 100, this gives me a really big negative number here, plus a smaller number, so it'll be negative over here. Now, I'm curious if this graph, if we use Desmos, if we're going to find that at -1, 0, +1, if our original graph is going to look like. So we're going to go to our friends, the Desmos, and we're going to go y equals 3x to the 5th. Oops. Ooh, come on. Y equals 3x to the 5th. Minus 5x to the 3rd. Oops. Minus 5x to the 3rd. All right. So, we're off a little bit. So we're showing between here. We're showing between here and here it's negative. This should have been positive, so maybe I did something wrong plugging it in. So we have positive slopes. So basically, I know our sine line is going to be off a little bit, but I know I have a positive slope here, I have a positive slope here. This is a point of inflection, so this is a negative slope or change direction. So let's go back and see what's happening at the other side of negative 1.291 and see where I made a mistake. Okay, I have negative, positive. So we're right here and here. So let's take that negative 100 and plug it back in. So negative 100 plugged in. If I went 3 times negative 100 raised to the 5th minus 5 times negative 100 raised to the 3rd. So you could just jump on using a graphing calculator and see what's going to happen. 3 times negative 100 raised to the 5th minus 5 times negative 100 raised to the 3rd. What did I do wrong? Where's it wrong? Third. -2. It's a huge number if it's negative. Oh! Dude. Friends, I goofed. And I know you all think I'm perfect, but I goofed. And this is where I goofed. These are right, but I'm going to show you why I was wrong. All right. So if I picked, say, 100 and I plugged it in, looking at this, that's going to give me a really big positive number. I'm good there. If I plugged in 0.5 into this, this is going to give me, you could easily plug in on a calculator. 15 times 0.5 raised to the 4th minus 15.5 raised to the 2nd. So this gives me a negative number. If I did the same thing here, I know that's going to give me a negative number. If I plugged the negative 100 into this, this is going to give me a positive number. If I took negative 100 and plugged it in there, it's going to give me a really big positive number. So there's our sine line on our G prime. I'm sorry. My mistake is I plugged it into the original. I made a mistake. I apologize. I got lucky on 3 out of the 4, but I just couldn't make it right. All right. So, my friends, could you finish 5, 6, and 7 on that sheet? And this will be something we will check on Thursday. By Thursday? Well, if you haven't heard, some of you aren't coming here to school tomorrow. Yeah, babe. Oh, saved it. I saved it. All right, now scissors. Here we go. Ready? How'd you get the big gash in your arm? Stir up through scissors at me. 9 News coming.